Here we have IIT JEE Main's math problem. Okay, let me go over the question. The product of all solutions of the equation e to the power of 5 times ln x whole square equals to x to the 8th power, where x is greater than 0 is. Okay, what I have to do is I have to solve for x in this equation. That is all solutions of this equation. And then I have to find the product of all solutions. Okay, now let me take the given equation as it is. It is e to the power of 5 times ln x the whole square equals to x to the power of 8. Here we have a logarithm. Ln means it's a natural logarithm. In the base of this natural logarithm is always e. So whenever we have the spelling ln, we have to understand this is natural logarithm and its base is e. Usually the base will not be mentioned when we have the spelling ln. Okay, now in my first step, what I'm going to do is I'm going to take natural logarithm on both sides of this equation. Then I'm getting a natural logarithm of e to the power of 5 times ln x the whole square equals to ln of x to the power of 8. Okay, now what I'm going to do is I'm going to use the power rule of logarithm on both sides. That is here this is the argument of the logarithm. So actually the argument is a power and this is the exponent we have over here. Using the power rule of logarithm, what I can do is I can move this exponent in front of the logarithm and this stuff will be multiplied by the logarithm. The same we'll have on the right side. Here the argument of a logarithm is a power. So we can move the exponent over here in front of the logarithm using the power rule of logarithm. Okay, then I'm getting 5 times ln x the whole square times ln e. So this is moved in front of the logarithm. Here we just have e. Let me write over here, and here we have 8 times ln x. Okay, already I said the ln is a natural logarithm and its base is e. Here, what is the argument of the logarithm? That is also e. In a logarithm, if the base and argument, both of them are same, the value of such logarithm is just 1. So here, for this logarithm, the base is e, the argument is also e. So the value of this logarithm is just 1. Then we get 5 times ln x, let me write it over here. 5 times ln x whole square times 1 equals to 8 times ln x. Then we get 5 times ln x whole square times 1 is still we get 5 times ln x whole square equals to 8 times ln x. Okay, now let me subtract 8 times ln x from both sides. Let me do it. 8 times ln x. When I do so, this positive 8 times ln x, negative 8 times ln x will cancel out. I'm getting 5 times ln x whole square, negative 8 times ln x equals to 0. Okay, now to make the solving process easier, what I'm going to do is I'm going to assign a new variable for this ln x, because here we find ln x, here we find ln x. Okay, let me assign a new variable. Let t equals to ln x. Then this equation will become what? It is 5 times t square negative 8 times t equals to 0. I just plugged in t for the ln x over here, ln x over here. Since this ln x is having exponent 2, we get 5t square. Okay, now let me consider a quadratic equation in standard form, that is ax square positive bx positive c equals to 0. Okay, if I solve a quadratic equation over here, how many values will I be getting for the variable x? I'll be getting 2 values because the degree of this equation is 2. For any quadratic equation, we'll have 2 solutions. Okay, without solving this quadratic equation, I want to get the sum of the 2 solutions. So what do we have to do? There is a formula for that one. Let me write it over here. Sum of the 2 solutions. The formula is negative b over a. Okay, so this is the formula. Negative b over a can be used to get the sum of the 2 values of x in this quadratic equation. Okay, here the original variable we have in the problem is this x, but now we have the equation, the new variable t. It was assigned by us to make the solving process easier. So if I here we have a quadratic equation in the variable t. If I solve this quadratic equation, how many values will I be getting for t? I'll be getting 2 values for t. One is t1 and the other one is t2. So like when I get 2 values for t, I'll be getting 2 values for x corresponding to the 2 values of t1 over here. That is, if I plug in the first value of t, that is t1 over here, I'll be getting a value for x. And when I plug in the second value of t, that is t2 over here, I'll be getting the second value of x. Okay, now let me assume when I get the value t1, when I get the first value t1 for t, the corresponding x value is x1. And also when I get the second value of t, that is t2, the corresponding x value is x2. Okay, then this equation will become what? Then we get t1 equals to ln x1 and t2 equals to ln x2. Okay, so here now it's clear. Solving the original equation, I'll be getting two values for x. One is x1 and the other one is x2. So according to the question, we have to find the product of solutions. Product of solutions means we have to find the product of x1 and x2, which are the two solutions of the given equation. Now my aim is to find the value of the product of x1 times x2. Okay, now what I'm going to do is I'm going to get the sum of the two solutions of this quadratic equation. So already we have assumed T1 and T2 are the two solutions of this quadratic equation. So sum of the two solutions means T1 positive T2, which is equal to negative B over A. So what do we have for B here? Actually here B is a coefficient of X. Here B is a coefficient of T, which is negative 8. Actually this equation is exactly in this form. Actually the constant term is missing. That is we have to assume the constant term is 0. For ax square we have 5t square. For bx we have negative 8t and c is 0. So b means coefficient of x. Here b means negative 8. So in this formula I have taken this negative sign. For b I plugged in the coefficient of t, that is negative 8, divided by a is a coefficient of x square. Here a is a coefficient of t square, that is 5. Then now we can replace this T1 by ln x1 and T2 by ln x2. Then I'm getting ln x1 positive ln x2 equals to negative times 90 will become positive 8 over 5. Okay, here I'm adding two logarithms at the same base because this one is natural logarithm, this one is also natural logarithm. Both the natural logarithms are having the base e. Whenever I add two logarithms with the same base, what I have to do is I have to take the logarithm once with the base what I have for the two logarithms, and I have to multiply the two arguments, that is x1 times x2 equals to 8 over 5. Okay, our aim is to find the product of all solutions. Already we have assumed that is x1 and x2 are the solutions of this equation. That is, we have to find the product x1 times x2. So for that we have to get of this natural logarithm. What do we have to do for that? So for that, what I have to do is I have to move this natural logarithm to the right side of the equation. When I move the natural logarithm to the right side of the equation, on the left side, I'll have x1 times x2 equals to, whenever I move logarithm from one side of the equation to the other side, so on the other side, we have to consider only the base of the logarithm. So the base of the logarithm ln, that is the base of the natural logarithm, is just c. The value which already exists on the other side will become the exponent of this base, that is 8 over 5. Okay, now I've got the product of all solutions of the given equation. So that is x1, x2 are the two solutions of the given equation. The product of all solutions is e to the power of 8 over 5. We find this e to the power of 8 over 5 in answer choice A. The correct answer choice for this question is A.